Bismillahirrahmanirrahim. Today we are going to go through a Edexcel GCSE Mathematics A Paper 1 non-calculated paper on the new syllabus, which is 1mao/1h. Now this is paper 1. There's also paper 2 which we'll do on another video. So you will find these videos on, if you search Imran Iqbal 1-to-1 tutor on YouTube. So that is my home page. So all you have to search is Imran Iqbal 1-to-1 tutor, and hopefully you'll find this paper uploaded later on this evening. Okay, so today's date is 24th of the 3rd of the 2013. Okay, this paper was originally done on the Monday 11th of June 2012, so it's quite a recent paper. It's done last year. Originally is 1 hour 45 minutes, and as you can see from the instructions, no calculator allowed. Okay, right. Today I'm using my Logitech C270 webcam to make this video. Let's see how good it is. Okay, let's go to question number 1. It says Sam wants to find out the types of film people like best. He's going to ask whether they like comedy films or action films or science fiction films or musicals best. It says design a suitable table for a data collection sheet he could use to collect this information. Okay, now the most basic type of chart that we can have is a tally stroke frequency. So what we need first of all, so we have here first of all the different types. So that could be one column. Okay, and the next, after we have type of film, we need the tally. So we would have here, we have comedy. Okay, and after we have tally, after we've done, for example, tally, say we had 2 of those, we had 5 of those, as an example, we would then need another column for frequency. Remember, this is a suitable table for data collection. So we're collecting the data in this table. Okay, so frequency would be 2, frequency would be 5, for example. So what we're going to do now, I'm just going to do roughly here for the moment. When you do this in exam, please use a ruler. Okay, so that's an example of how we do a table. Okay, next question. It says here, Sam collects his data by asking 10 students in his class at school. This might not be a good way to find out the types of film people like best. Give one reason why. So, first of all, so he's going to ask 10 students in his class. So 10 students in his class. So if they're going to be 10 students in his class, they're most likely going to be students of the same age. Okay, so all students have the same age. So these are some possible. He goes, give one reason. I'm going to give you a couple of reasons. So you write any of these. The sample of 10 is too small. Sample size sample size is too small, the sample will be biased because they will all be his students in one class. So the same age group possibly have the same kind of likes and also the same school. So he's not taking the sample out to the larger public, because he says that he's going to ask, he wants to find out what types of people. So people has different age groups, different backgrounds, whereas here in the question, he has now singled it down to 10 students in his class. So some of them are 4 possible answers you could give here for this question. Okay, let's move on to the next question. Okay, question number 2. The diagram shows a patio in the shape of a rectangle. The patio is 3.6 meters long by 3 meters wide. Matthew is going to cover the patio with paving slabs. Each paving slab is a square of side 60 centimeters. Okay, now remember, we got centimeters here and meters here. We got 2 different units being used straight away. Matthew buys 32 of the paving slabs. Does Matthew buy enough paving slabs to cover the patio? Now, first of all, 60 centimeters. Let's change them to meters by dividing it by 100. And that'll give you 0.6 meter slab. Okay. Now, this is 3.6 meters. That's 0.6 meters. Okay, we can either think how many 0.6s can we fit into 3.6 along here. Okay, so if we do now 3.6 divided by 0.6, what we can do here, we can do the division quickly. We time this one by 10, time this one by 10. So it converts it from decimal on the bottom to a nice whole number. So you have 36 divided by 6, and that gives you 6. So we have on the bottom 1, 2, 3, 4, 5, 6. Sorry, my slabs are not drawn uniformly. So we'll get, okay, so we'll get 6 slabs along the bottom. And now we have 3 meters. We divide that by 0.6. Now, again, change that into a whole number, time that by 10, time that by 10. That gives you 30 divided by 6 is equal to 5. This is a technique for us dividing by decimal number, but without dividing by decimal number, converting into a whole number. So we'll fit 5 slabs along the height. So we have 1, 2, 3, 4, and 5. Okay. So from this diagram, we can see now that we will have 6 columns. Okay, and we time that by 5 rows. So we got here 1, 2, 3, 4, 5, 6. And it's going to happen how many times? 1, 2, 3, 4, 5 times. So that will give us an answer of 30 slabs. Okay. And the question says here, does Matthew buy enough paving slabs to cover the patio? You must show all your working. And he buys originally 32. And we need 30. So the answer is yes. Matthew has enough paving slabs. He only needs 30 and has 32. Okay, moving on to the next question. The next question says, the paving slabs cost £8.63 each. Work out the total cost of the 32 paving slabs. So now that he's bought 32 slabs, we need to do 32 times by 8.63. So that's just that's the calculation we need to do. It is a multiplication calculation because each slab costs £8.63 and we got 32 of them. So for this kind of question, we're going to set it out in the traditional long multiplication style. So first of all, we have to multiply everything by the first number on the first line, second number on the second line, not forgetting to put in the 0. So we have 3 times by 2, that will give you 6. 6 times by 2 will give you 12 with a little baby remainder 1. 8 times by 2 is 16, add the 1 is 17. Be careful to keep all your numbers in the correct columns. So as you put the numbers, don't squeeze them up, don't push them apart too much. Now we move into the second digit, second line. 3 times by 3 is 9. 6 times by 3 is 18. 8 times by 3 is 24. Add 1 is 25. So now we need to add these two. 6 add nothing is 6. 2 add 9 is 11. So we have 8, 9, 9 add 7, 16. That one, we get rid of that now. We're not using that again. That's already been used. 5 add 1 is 6. Add the 1, will give you 7 and 2. We haven't finished here. This question has 2 decimal places. 1, 2 in the question. So you will have 2 decimal places in the answer. So let's put them in. 1, 2. So the final cost should be £276 and 16 pence. Okay, let's move on. Okay, I think for this one I'm going to need to use a ruler. Okay, so this is this question number 2 that we've just done over here. Question number 2 is one of the new style of questions, functional maths. We call it functional skills, where they give you a real life situation and they want you to work out how many slabs you need, what will be the cost. So this is the kind of thing that you need to do yourself if you're doing this at home for your garden. Now if we move on to the next question, Bill uses his van to deliver parcels. Now this is another kind of problem solving questions. Okay, so let's go to the question. Bill uses his van to deliver parcels. For each parcel Bill delivers, there is a fixed charge plus £1 for each mile. So this is the beginning of a kind of formula. You can use the graph to find the total cost of having parcels delivered by Bill. So if you look over here, when he has done 0 miles, when Bill has done 0 miles, his charge already, before he even starts, his charge is £10. So that must be our fixed charge. And he's going to charge £1 per mile. Okay. Okay. question goes, how much is the fixed charge? So the fixed charge, as I said, will be the value when he's done 0 miles. Okay, that's his fixed charge, £10. It's where the graph intersects the y-axis. So we can write over here, £10. Now we've got a different driver now, the Ed. So initially we had Bill. So he's driver 1. And now we have Ed. He is driver 2. Okay. Now with Ed, he uses a different type of charging system. Ed uses a van to deliver parcels. For each parcel Ed delivers, it costs £1.50 for each mile. There's no fixed charge. So if there's no fixed charge, that means his graph will start from the origin and £1.50 a mile. Now if he's done 10 miles, so we have to do 10 times by £1.50. That will give us £15. So at 10 mile point, he's charged £15. So here's 10, and then we're going to have 15 is going to be halfway. So that's 15. Okay, let's pick another point. Let's pick 20 to plot another point. So that's one of my points. That's one of my points. Okay, so we're doing now 20 miles time by £1.50, and that'll be, if 10 to 20 we double it, we double the cost. So back to the graph, 20 miles it will take there we go. Now we've got some point that's actually touched the other line. Now we get our ruler and we try our best to make this line as smooth and as clean as possible. I'm just going to change color. Okay, so the purple line is going to be Ed's. And the initial line was Bill. So we have Bill and Ed's. The question says now, compare the cost of having a parcel delivered by Bill with the cost of having a parcel delivered by Ed. Now, this question, okay, let's answer this question now. So to answer that question, we have to look at 3 sections of the graph. Let me just change color once more. Okay, the 3 sections I want to look at is this area here, this area which is before the point where they intersect. Okay, and then we're going to look at the point. Then we're going to look at the point where they actually intersect. And then we're going to look at the point okay. So we're going to analyze these 3 sections, and from these 3 sections we should be able to make a good comparison. Now in the green section here, where Ed's line is below the line of Bill, this tells us here that Ed's charges are lower. So for 10 miles, Ed only charged £15, whereas Bill charged £20. So because the purple line is below the black line, that means the charges are less. So we can say So the cutoff point is 20 miles. So below 20 miles, we know that the purple line, which was Ed is cheaper, okay, cheaper than Bill. That's our first statement. That is the statement to do with this green section over here, because the purple line is below. Now we're looking at the next section where the blue section, where the lines intersect. Now that intersect happens, if you look at the graph, at 20 and 30. So at 20 miles, so at 20 miles, Ed and Bill have equal charges. Okay, so we described now the two sections. The green section here was we say Ed is cheaper. At this point, they are both equal price. And now we're going to look at this next orange section over here. In this next orange section over here, we can see now that Ed, who was cheaper over here, has now become more expensive because his graph is higher than the Bill's graph. So at 30 miles, Bill is 40. At 30 miles, Ed is 45, for example. So now Ed has become more expensive. So the last section, the orange section over here, you can describe it. So after 20 miles, okay, so after 20 miles, it is more expensive, or Bill is cheaper. And that will give you the full marks because we've analyzed the graph on each point, each section. The section where one was below. So we have described the green section, the intersecting section, and the rest of the graph. So we describe all three main points of the graph. That will give you the full marks. Okay, let's move on to question number 4. Okay, right. Here are the speeds in miles per hour of 16 cars. Draw an ordered stem and leaf diagram for these speeds. Okay. So now, first of all, we need to also, before we start, we need to start with the key. So the key will tell us for example, that there 39 stands for 39 miles per hour. So I'm looking at that number there, using that as a key. So the number 3, if it's on the left hand side of the line, that's your 30 representing, and the 9 representing the units of the number 39. We'll see that in more detail when we come over here and we start drawing our graph. So we need to look, the lowest number that we have, if you look along here, it will be a number starting with 20. We got 29. So we need to start with 20. Obviously, the next 10 after 20 is 30. And then after 30, the next 10 is 40. And then the next one we have is 50. So that's what the key. This here stands for the tens. 20, 30, 40, and 50. Okay. Right. Now let's have a look at how many 20s we have. We have one number which is 29. Let's cross that out. Let's put that in. And then we look at the 30s. We have 31. And the idea is to put the numbers in order. So 31 goes first. Then we have 33. Then after 33, we have 35. After 35, the next one we're going to have is 36. You need to make sure that the numbers are in columns and they're not moving around. So if I choose quickly get a pencil and a mark on there lightly just to indicate that these are my, like, in a sense, invisible columns. All the numbers should line up nicely and beautifully. Okay, so we've done all the numbers in the 30s. Now we're going to look at the 40s. We've got quite a few in the 40s. Okay, we have 42, 43. We have another 43. So 42, 43, and 43. Then we go to 44. 44, we need to move up a bit. 44. And then we have 46, 48. And then last but not least, we have 49. Okay, now we're moving to the 50 zone. Okay, I'm going to struggle to get them both in at the same time. So I'll just move my graph up a bit in the end. Okay, 50s. So what number do we have 50s? I'll do here a little baby one here, and then we'll copy it down. So 50, we have 52, 54, and 55. So we have 52, 54, 55. I'm going to copy these over here because we can't get the whole page up on the screen at the same time. So now we're going to have 52, 54, 55. Okay, and that's our ordered stem and leaf diagram. Just to make sure that we've got all the numbers in there, we need to just quickly count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. And are we missing a number? We are missing a number, and that is one of the 30s. So we go back and look at the 30s. Is the one that we haven't crossed out. It's 39. So that check is very important, and we found that one number is missing, and that number is there. Cross that out, put that back in, and now the diagram is complete and it's been checked. So missing out numbers, when you start crossing and making lines on there, it can be quite easy to miss out the numbers. So we need to check them as I've just done, and we found one number missing and we put it back in. All done, no harm done. Okay, let's move on to the next question, which is question number 5. Question number 5. You can work out the amount of medicine, C, milliliters, to give to a child by using the formula C equals MA divided by 150. M is the age of the child in months, A is the adult dose in milliliters. A child is 30 months old. So the child is 30 months old. That is the M value. And the adult's dose is 40. That is the A value. Work out the amount of medicine you can give to the child. So this question is a substitution question. So we say C is equal to M, A. M times by A. M is 30. A is 40. And we divide it all by 150. Okay, remember this is a non-calculator paper, so we need to use the calculator that we're all born with. That's called our brains. Okay, so let's try to sort this out without using calculator. Now, because we have a fraction, that's a product, we can simplify. If I divide 150 by 10, I lose a 0. If I divide 40 by 10, I lose a 0. Now we've got 30 and 15. If I divide 15 by 15, I get 1. If I divide 30 by 15, I get 2. Okay, this is the skill that we learned in normal fractions. Okay, so now what we're left with, we have to multiply the two top numbers. So we're left with 2 and 4. And our bottom number is just 1. So we end up with 2 times by 4 is 8. 8 divided by 1 is 8. So That's over here is 8 milliliters. Okay. Right, time to move on to the next question. That was a nice straightforward substitution question. Okay, we are now moving on to question number 6. Here are the ingredients needed to make 12 shortcakes. Liz makes some shortcakes. She uses 25 milliliters of milk. How many shortcakes does Liz make? So, we need to look at the milk content of the 12 shortcakes, which is 10. And now she's going to use 25. So we've got to say, how do we get from 10 to 25? Okay, 10 to 25. We need to multiply. So our scale factor will be equal to 2.5. So we have increased the 10 milliliters to get to 25 milliliters by a factor of 2.5. And the way to work that out is to say, well, 25, reverse operation, divided by 10 will give us 2.5. So that's the calculation that I've done in my head. Okay, so our scale factor is 2.5 for this. How many shortcakes does Liz make? Now, if I've multiplied this by 2.5, I have to multiply that by 2.5 as well to tell us how many shortcakes she made. So we have 12 multiplied by 2.5. Now, the way I like to do this question, because it is a question without using calculators, I say 12 times by 2, and then 12 times by a half, which is the 0.5. 12 times by 2 is 24, and 12 times by a half is, 12 times by half means half of 12. So we have 24 shortcakes, 6 shortcakes, add them up, is 30. So she made 30 shortcakes. 30. Now it says Robert has 500 grams of sugar, 1000 grams of butter, 1000 grams of flour, 500 milliliters of milk. Work out the greatest number of shortcakes Robert can make. This question requires much more thinking because we've got all different amounts of scale factor. So from 50 to 500. So let's do them one by one. So the sugar was 50, now it's become 500. Okay. The butter was 200, and now the butter is 1000. Okay, next we have the flour was 200, and now the flour is 1000. Okay, we have the milk was 10 mil, and now the milk is 500 mil. Okay, let's work out the scale factors now for these individual questions. Okay, 50 to 500, we've added another 0 on. So we increased it by a factor of 10. 200 to 1000, 200 to 1000, that's a nice easy one, times it by 5. 200 to 1000 again is similar, times by 5. 10 to 500, well, 10 to 50 will times by 5, and then we add another 0. So this one here, we've made it 50 times greater. So we have to see, we got enough ingredients to So we look at all the different scale factors. We have 10 for the sugar, 5 for the butter, and then we have 5 for the flour and 50 for the milk. So even though we got enough milk to make 50 lots of our original 12, we don't have enough for 50 lots of the other ingredients. So we have to look for the smallest number. So if we got enough for 5 more lots of 12 shortcakes, that's all we got ingredients to make. So here we got surplus ingredients. Here we got surplus for the 5, surplus 5. So we have to choose 5 lots of 12. So 5 sets of the 12, or 5 lots of 12. So 5 times by 12 will give us an answer of . So the answer for this one is we have enough ingredients for 60 shortcakes, or 5 times what's needed to make 12. So even though we have got 10 times the amount of sugar and 50 times the amount of milk, because we don't have similar amounts of flour and butter, we can't make those extra sets. That just be surplus ingredients. Okay, let's quickly move on to the next question. Question number 7. Question number 7. Let's position it right in the camera. Okay, buses to Acton leave a bus station every 24 minutes. Buses to Barton leave the same bus station every 20 minutes. A bus to Acton and a bus to Barton leave the bus station at 9 a.m. When will a bus to Acton and a bus to Barton next leave the next bus station at the same time? What we need to do here is we got one leaving every 24 minutes, one leaving every 20 minutes. We just need to count in the 24 times table and the 20 times table. So to see when the numbers will match, we get an LCM. 20, 40, 60, 80, 100, 120, and so on and so on. So these are minutes. Okay, don't forget, starts at 9 a.m. And then we're going to add these minutes on. That's 9:20, 9:40, 9:60, and that'll be then 10 o'clock, and so on and so on. Now 24 minutes, let's do our 24. So the first one will leave at 9:24. 24 minutes past, then after 24, we'll leave at 48. Okay, and then we add another 24. That'll give you 72. Add another 24. That'll give you 96. Add another 24. That will give you 120. So we see here that 9 o'clock plus another 120 minutes is when they will both leave the bus station at the same time. So 120 minutes, we divide that by 60 minutes. That gives us 2 hours. So we started at 9 a.m. and then we added 2 hours when they're going to meet again, and that will give us okay. Let's quickly move on. Okay, we're already 40 minutes, nearly 40 minutes into this lesson, and we've only reached question number 8. Okay, don't forget that because this video will be on YouTube, you can go forward, backwards, you can pause the video, you can quickly go through the video, rewind the video, so however it's easy for you to understand and get benefit from this video. Okay, next, we're moving on to one of my favorite subjects, algebra. It says expand. Expand means to multiply out these brackets. So we start from the outside. We say 3 times by 2y. And let me say 3 times by minus 5. So 3 times by 2y will give us an answer of 6y. And 3 times by minus 5 will give us an answer of minus 15. So the sign in between these two these two items here comes automatically from the question. So I'm not guessing, do I put plus here, minus here, do I copy that minus down? We look at the calculation. This calculation generates its own sign. So it's expand. So across here, we write 6y minus 15. Time for the next question. It says factorize completely. Okay, when it says factorize completely, this looks like a quadratic equation, but it is not a quadratic equation. Okay, we've got an x squared in there, we've got an xy term in there, and we've got no constant term at the end. So we're going to factorize it using common factors. So we have to see, what do these share in common? Now in the number 8 and the number 4, number 8 factors are 4 times by 2 and 4 factors 4 times by 1. So they both share a 4 in common. We have x squared and xy. X squared is made up of x times by y. That's made up of x times, pardon me, that's made up of x times by x. That's made up of x times by y. Okay. Okay, we seem to have got my circles crossed there. So x squared is x times by x times by y. Now, what do they have in common? An x here and an x there. So we can split this up into what? So we have 4x times by 2x. That's going to be 4x times by y. So 8x squared has got common 4x as a common factor. And then we have 4xy has got 4 and x common. So that's over here. So we're going to circle those. And we're going to take them out. Take them out by the scruff of the neck. Okay, different color, please. That one's too light. That's better. So we got now 4x, bracket, drop. Drop the 2x down, drop the plus down, drop the y down, and we're done. Okay, that's what I mean by factorize completely. Now, how do we know we factorize completely? Because when we look at this part over here, there should be nothing in here that we can factorize again. There's no common factors. So 2x and y, there's nothing else you can take out of them to put over there, so you're finished. That's done. So we can copy that across over here on the side. Okay, we're done on that question. That's been factorized completely. Okay, we've got to make h the subject of the formula. This topic is called rearranging equations. Or rearranging formula. Now, it says t is equal to gh over 10. And as I say, always start with the h, the item that you're looking for. Start there. Start there. And we look at what's being done to the h. I call this first stage identifying. So we need to identify the actions that we're doing. Let's do that first. So h, at the moment, this, even though I've enlarged this paper, it's still a bit small. I'm just going to write down underneath, a bit more bigger. Okay, so I'm going to start the h is what I'm looking to make the subject. H has been multiplied by 10. I'm going to call this my first action. Then it's been divided by 10. I'm going to call that my second action. Okay, so the first action is time by g. The second action is divide by 10. Now, when we solve, we start at the last action. So we move the second action first and then the first action. So we do solve in reverse order. So we start with the last action, which is time by divide by 10. Opposite divide by 10 will be time by 10. Opposite divide by 10 on this side is time by 10 on that side. So that will give you 10t is equal to g time by h. Now, so far we've done one step. Now we need to remove the second action. Now you've got to move the first action. That's next. The first action was time by g. There it is. Opposite time by g is divide by g. So we say h is equal to 10t divided by g. Okay. If you need to go through this method again, you can easily just rewind that part of the video on YouTube and go through again, because I need to move on, make progress. Okay, question number 9. Describe fully the single transformation that maps triangle A onto triangle B. Now, this is one of the questions that can be asked in terms of a transformation. Now, if you look at the question, this part that was on the bottom is now on the top. There doesn't seem to be a mirror line anywhere, but it looks like if we were to go in between these 2 points and join them up and turn them around, we will get our B point. Okay, and we can use a bit of tracing paper to show this. Okay, just give me a moment. So let's check my theory that the center of rotation is there. Okay, right. Do we have enough tracing paper? I'm sure we do. Okay. Put the corners in. So that there is my center of rotation. And we've got to turn the shape so that A goes on to B. So let's try it. Let's take our time, get it properly. I'm going to press hard down on here now. And I'm going to spin the paper around. Spin the paper around. And bring the paper down a bit. And beautiful. Lovely. Absolutely lovely. So we know that's confirmed. So that looked like our center of rotation, and it actually is. Now what we need to do is work out that point. So we're going to describe the center of rotation. So it is a rotation. It's gone from the bottom to the top. So it's gone through 180 degrees. Now when you go through 180 degrees, because it's half a turn, it doesn't really matter whether it's clockwise or anti-clockwise. So we can just say rotation 180 degrees, but for the sake of argument, we'll write down clockwise and about. Where was it about? The about is talking about the center. So the center has a coordinates of 3 along the x and 3 along the y. So now this will give you the full 3 marks. Rotation, you have angle, direction, and that. Okay. Right, let's move on to the next question. Don't forget, anytime you want to go back to the method of the question, pause the video on YouTube and rewind the video using the bar on the bottom, and then you can watch it again. Okay, we have got left lots of questions. 26 we got. So we are 50 minutes into the video. Okay, question number 10. Here's another one of those questions, which is our functional skills. Okay. Rail tickets and cheap trains are two websites selling train tickets. Each of the websites adds a credit card charge and a booking fee to the ticket price. Okay, so the first company and the second company. So the credit card charge is 2.25% plus a booking fee of 80p. 1.5% of the ticket price is the credit card charge and 1.90 ticket fee. So Nadia wants to buy a train ticket. The ticket price is £60 on each website. Nadia will pay by credit card. Will it be cheaper for Nadia from the company number 1 or company number 2? So this is the kind of situation or scenario that we can face on a normal everyday basis when we are catching a train, booking an air ticket, whatever we're doing. This is the kind of situation we are faced. Which website shall I go through? Shall I go to this company, that company, which one's cheaper? So this is going to be now looking at the technique for working it out. Let's divide the page into half. So the credit card charge is 2.25%. So here we go. £60. Let's convert that into pence. So the answer for that will be, okay, now we need to work out 2.25%. So let's work out 1%. So to get to 1%, what we do? Because 1% is 1 over 100. It's 1/100th. So 1/100th divided by 100. So 1% is 60p. I want another 1%. That's another 60p. I want now 0.5% to get to my required total of 2 and a half. And then actually we've got to divide that into a half again to get quarters. Okay, we will come to 2.5 in a bit. So we have 60p, 60p, and half. How do we get from 1 to a half? Divide by 2. So that will give you 60 divided by 2 will give you 30p. So far we have 1%, 2%, 2.5, but we want 2.25. So we need to now, how do we get from half to a quarter? Divide by 2. Divide this side by 2. 15. So what we're looking for here, 1%, another 1%. We don't need that anymore. Okay, so if we add all these up, 1 add 1 is 2, 2 add a quarter is 2.25%, 60p add 60p is 120p, 120p add 15p is 135p. So we worked out that the credit card charge of 2.25% is 135p. And then we've got to add the 80p. That's credit card charge. And this one's going to be the booking fee. So add them up. Working pence was nice and easy without the decimal points. 5 add nothing is 5. 3 add 8 is 11. And then we have £2, 215p. Or we can say, okay, right. So we worked out that the first company here will charge us £2.15 extra. £2.15 extra. So let's move on to the next company. So it says here that the credit card charge is 1.5%. But we already worked out 1%. Just copy across. So 1% is 60p. And we already worked out 0.5%, we can just copy across. 0.5% is 30p, and then we add them up. 1 at half is 1.5%. 60p at 30p is 90p. Okay, so we know that company rail tickets gonna charge us £2.15 extra, whereas the cheap trains are gonna charge this percentage, and then we're gonna add on to that booking fee of £1.90 to give us the total. So that'll give you 0, 9 at 9, that will give you 18. So that'll give you, keep in pence, then we change it. Okay. Right. Okay, so we have 100, we have 90p. 90p was the credit card charge, and then we had £1.19 was the booking fee, and we add them together, that gives you 280p. So we say the answer is £2.80. Okay, so we know now that this company is cheaper. So £2.15 extra is less than £2.80 extra. So rail tickets will be cheaper. Okay, let's move on. Okay, here's our next question. Let me just straighten the paper up so you get a nice clean image on the YouTube video. Okay, the diagram shows a parallelogram. This is the shape. The size, angles, and degrees are this: 2x, 3x minus 15, 2x, 2x plus 24. You're probably thinking, what kind of angles are these? This is angles given in algebraic terms. And these angles have been written over here because we work out the value of x. What we need to do first of all is to form an equation, and then we need to solve the equation. So forming the equation, so let's look at the shape. What is the property of a quadrilateral? This is a quadrilateral, which means it's a four-sided shape. We know that all of these angles, they must add up to 360 degrees. Okay, so the angle sum of a quadrilateral is these four angles here must add up to 360. That's the fact that we know, as that's the property of the shape. So let's put that together in let's form an equation. So we can say 2x, start from here, so we can say here 2x plus 3x minus 15 plus 2x plus 2x plus 24 is equal to 360. Let's leave that out. Now what we need to do, we have here what's called It's a type of a linear equation. We have x's and numbers. So we need to simplify the x's with the x's and the numbers with the numbers. Let's change color. So let's look at our x terms. Oh, we can actually use this on top here to help us. So 2x add 3x will give you 5x. 5x add 2x will give you 7x. 7x add 2x will give you 9x. Now, we have a minus 15 and plus 24. Minus 15 and plus 24, which is the same as 24 take away 15, which will give you 9. Okay. So first of all, we've formed the equation. We have now simplified the equation. Let's change color once more. Simplifying the equation. Now we need to solve the equation. Now to solve this equation, we start at x. We look at the actions. Time by 9 is the first action. Add 9 is the second action. And as mentioned in the previous question, when we identify the actions, we solve by doing the last action first. So plus 9 goes over, becomes a minus 9. So you have 360 minus 9. Okay, and then the first action goes now. Opposite time by 9 is divide by 9. So x is equal to 351 divided by 9. Remember, this is a non-calculator paper. So the calculator is not allowed. So we use the old school method called the bus stop method that most students will be familiar with. So we have 351 divided by 9. So we say how many 9s go into 3 is nothing, and the whole number becomes the remainder. How many 9s go into 35? So you're thinking about our times tables. Okay, so 9 times by 4 will give you 36, so we don't have enough. So we have to be 3. So 9 times by 3 will give you 27. So we need to work out how much remainder we have between 27 and 35, and that will give you 8. How many 9s go into 81? And that is 9. So we have now worked out the value of x. Okay, let's move on to the next question. It says Jane has a carton of orange juice. The carton is in the shape of a cuboid. The depth of the orange juice in the carton is 8 centimeters. Jane closes the carton, then she turns the carton over so it stands on the shaded face, which is one here. We'll work out the depth in centimeters of the orange juice now. Okay. First of all, we know the depth of the orange juice in the carton is currently 8 centimeters. So if you want to work out the volume of the juice in the carton, we need to use our traditional formula. So we say volume is equal to length time by width time by height. So my length is 6, my width is 10, and my height is 8. Okay, to make it easy, 6 times by 1 is 6, times by 8 is 48, and then put the 0 back on. So we know that the current volume is equal to 480 centimeters cubed. Okay, now that is the volume of orange juice we have. Now if we turn the shape, so this is going to be, the shape is going to turn around, so it will sit on this face here. So we have a new diagram. Okay, now if you look at the original diagram here, that 6 here will be here, and the height of 20 will now be the length. So this will be 20, that will be now sitting on the floor, sitting flat, 20, and we need to work out the depth. So the thing that we need to work out is, how high will the juice be now? So we now, the volume is fixed at 480 centimeters cubed. We know the length, we know the width, but we don't know the height. So I call these kind of questions a reverse question, a reverse volume question. A reverse volume question meaning that we start off with the volume, you've got to work out one of the original values. So V equals, the formula is exactly the same again. Now we know the answer. So the answer is 480. That's the answer that came from the first part. The length we know is 20. So the length is equal to 20. The width is equal to 6. And the height we leave as h. So this is the bit here that we're trying to work out. So what we need to do first of all, opposite of multiplying by 20 is, start reversing the actions. We got 20 times by 6 times by h. I'm just moving in steps, make it easy. So we divide this by 10, divide this by 10. We got 48 divided by 2. And the opposite time by 6. 24 divided by 6 is equal to 4 centimeters. So this question, it looks quite straightforward, but it involved a nice straightforward volume question followed by a reverse volume question. Okay, I want you to have a look at this next question and see what you think of this next question. Okay, question number 13. We have the diagram shows a regular hexagon and a regular octagon, and this is our work on polygons. Now, what we need to do, simply is first of all split this angle x into two parts. I'm going to call this A, call this B. So we can say easily A at B is equal to x. Now, we have formulas for working out properties of polygons. The word regular is very important. It means all the sides are equal and all the internal angles are equal. Now, if I want to work out one external angle, so one external angle is equal to 360 degrees divided by the number of sides n. So n is the number of sides. Okay, so what do we have here? So the external angle is A. So if we call this shape 1, shape 2. So we have 1, 2, 3, 4, 5, 6 sides. So we know that A, which is called an external angle. An external angle, you just extend the line from the shape and go outwards, and that gives you what's called an external angle. So A, we worked out to be 60. Sorry, you couldn't see that. Okay. Right, now we're going to do an external angle for shape 2. Shape 2 says an octagon. Octagon means it has 8 sides. Hexagon means 6 sides. So same formula. So this is the external angle here, by the way. This angle. So we say one external angle. One external angle is equal to 360 degrees divided by the number of sides. The external angle is called B. So B is equal to 360 degrees divided by the number of sides. It's an octagon, so it's 8 sides. So we have 360 divided by 8. 360 divided by 8. That will give us an angle of 45 degrees. So we have the two angles, A and B. So A is 60. That one's 45. Now to work out the angle that they're looking for, which is this one here, you have to add them up. So 60 add 45 will give us an answer of 105 degrees. So we have to work out one external angle for that part of the shape, one external angle for this shape here, work them both out, add them up, gives us the answer. Done. Okay. This next question, the diagram shows the position of a lighthouse L and a harbor H. The scale of the diagram is 1 centimeter, represents 5 kilometers. Since I'm using an enlarged piece of paper, this is an A3 size. You have to give me a moment while I get the other size and measure from the original size. Okay, so we have L and H. Just give me a moment. Okay, so this distance from here to here, I've just confirmed it by measuring a correct scale diagram. That is 7 centimeters using a ruler. Okay. Scale is 1 centimeter is 5 kilometers. Work out the real distance between L and H. So 7 centimeters times by 7 times by 7. So 7 centimeters on our bearing and on our scale diagram here is worth 35 kilometers. So make sure you put down 35 in kilometers as well for your units, because measure the bearing of H from L. Okay, for that we're going to need to use a protractor. Now the key part here is the bearing of H from. That word from tells you that we are going to start at L. Now bearings are always measured from north. They're always measured in a clockwise direction, and they always are given in 3 digits. So them are the 3 rules. Start from north, measure clockwise, and give in 3 digits. That's what defines a bearing for us. Okay, so first of all, the correct use of your protractor. I always like to start my protractor with the 0 facing north. We need to get this point here onto the corner over here. Move into position. Take your time to position it, so you can take your time to get this part right. Okay, so I've got it exactly in the right place I want it. I've got my black line on the 0 on the north line, so I'm going to measure along this clockwise direction. I'm just going to use my line for emphasis, and then we stop over here, and we read the scale on the outside. I don't know whether you can see from the webcam picture, but we have here nice and bang on to 110 degrees. 110 degrees is already in 3 digits, so we don't need to do any further alterations to that. So the answer is the bearing is 110 degrees. Okay, it says here a boat B is 20 kilometers from H on a bearing of 0 to 40. On the diagram, mark the position of boat B with a cross. Well, first of all, let's do our 40 degrees. So again, put the T junction here onto here. Put that 0 degrees line on the black line, on the north line. Okay, and then we're going to start from this as north. 10, 20, 30, 40. So our question is going to be in this direction. So I'll just quickly change to a pencil. Okay, and the question says he wants to be 20 kilometers. 20 kilometers. So we need to change that into centimeters for our scale. So we know 1 centimeter is 5 kilometers in the scale. So how does 5 become 20? 5 to 20, what do? We time by 4. So if we time the kilometers by 4, you have to times the centimeters by 4 as well. 1 time by 4 is 4. So we need to measure 4 centimeters along this line and then mark it with the position X. Okay, for the sake of argument, even though this is a large paper, I am going to mark 4 on here. And when you do yours on a proper size paper, you'll get it right. Okay, so on your paper here, when you do yours, you need to make sure that this part here is 4 centimeters. And then we mark it with an X and label it B. Okay, that's that question done. Okay, Harry grows tomatoes. Question number 15. We're moving on to cumulative frequency. Okay, and the next question is going to be box plots. Okay, it says that Harry gave fertilizer. This year he put his tomato plants into 2 groups, group A and B. Harry gave fertilizer to tomato plants in group A. He did not give to B. Harry weighed 60 tomatoes. Key number 60. The cumulative frequency graph shows some information about these weights. The question says at the bottom, use the graph to find an estimate for the median. So let's get the graph in the correct position. It's a bit difficult to get it all on. Okay, just give me a moment while I do some focusing. Okay, so we have 60 values. The word, an estimate for the median word means the middle value. Okay, I'm writing them in the wrong place. Excuse me for a second while I just try to get this right. So the median is the middle value. Okay, if we have 60 values, if you want to work out the middle value, what do we do? 60 divided by 2 is the 30th value. So we come to the 30th value here. We go across. As soon as it touches the graph, we bring it straight down. Okay, so the median value starts from here. That's the 30th value. And it finishes over here. So this here is the median value. This is the median value and not this. We start the median calculation from this side. We hit the graph, we bring down. That's the answer over here. A lot of students think that's the median value. No, that's the answer. So the estimate for the median rate is approximately 170, and grams is already given. 170 grams. Okay. Because the 60 tomatoes from group A had a minimum weight of 153 grams. Now, if we're going to be doing a box plot, which they want us to do, 153, the minimum would be here. 151, 2, 3. We do that with a line. Okay, a long line, a medium-sized line. That's my minimum value. Has a maximum value of 186. We go 186. There's my maximum value. Okay, now if you look at the bottom box plot here, we have minimum, maximum, lower quartile, upper quartile, and this one here is called the median. This one here. So we need more information to come, because use this information and the cumulative frequency graph to show a box plot for the group A ones. So we have the minimum, maximum. We need to know the lower quartile, upper quartile. So we turn back. Now, if 60 is the maximum, we have to do now 60 divided by 4 is equal to 15. So 15, every 15 values is the quarter. So 10, 15. That is the starting of our lower quartile value. That's the halfway value. And add another 15 gives us 30 at 15 gives us 45. And that's going to be the start of our upper quartile. So now let's draw some lines across for that. So the lower quartile this is the lower quartile value here. So then we go to the upper quartile, start point. We go across. When we stop at the graph, bring it straight down. And there is the upper quartile value. Okay. Now, the lower quartile value according to this will be 160, 1, 2, 3, 4, 5. And our upper quartile value will be 170. That's 175. So now back to this. We know our lower quartile is 165 and the upper quartile is 175. So 165, we can start to draw the graph, which is going to be here, and 175 is going to be here. Okay, one value missing. If you look over here, we need the median value. So we go back to our graph, and the median value is 170. Okay, so there we go. Okay, there's our two. That's group A, that's group B. That's our lower quartile, upper quartile, median. Compare the distribution of the weights of the tomatoes from group A with the distribution of the weights of the tomatoes from group B. This is the common type of question we have when we have a box plot, is to look at the box plots and say, what can we see is happening? I'm going to do that for you to have a look at for the first few seconds, see what you think of before I carry on. And the things we need to look at are values like, for example, the range. Okay. We're looking at the interquartile range as well, how far that is, and the median values. We need to compare those, so comparisons on that. Okay, so what is one of the things that we can see? And we can see that the range and the interquartile range is smaller for group B than it is for group A. So the range is, this distance here is less than that one. Okay, the interquartile range here goes from 165, that's 10, but it's less than 10. Is less than group A. Okay, that's okay. The point we can point at. Now that's the median value here, which is 170, and the median value here is 162. So the median group A okay, done. 2 marks. Mention range and interquartile and median. Enough for 2 marks. Okay, the video is getting on towards 1.5 hours now. Okay, simplify When you raise an index to another index, the rule is that we multiply them. So that will give us an answer of m to the minus 10. Okay, factorize. When you factorize a quadratic equation, this is a quadratic equation of the format ax squared at bx at c. What we need to do is, we need to find two numbers that when you multiply them together, it gives you the c value, which is minus 10. And when you add them, it gives you the b value, which is plus 3. So, what two numbers multiply give you minus 10? Let's have a look. You can have minus 1 times by plus 10, plus 1 times by minus 10, minus 2 times by plus 5, plus 2 times by minus 5. But it must give us a total of 3. So that's not good. That's not good. That will give us a total of 3. That will give us minus 3. So that one looks good. Let's put it in here and check it. So minus 2 times by plus 5 is minus 10. First rule condition checked. Minus 2 add 5 plus 3. Lovely. Done. Copy that into here. Copy that into there. And the job's done. Okay, the next one goes right on the value of 10 to the power of 0. Anything to the power of 0 just gives you 1. Okay, so question number 17a is done. And now we're moving on to 17b. Looking at standard form, the minus 5 indicates that when you write the 6.7 down, we need to move to the left. 1, 2, 3, 4, 5 numbers drop. So 0, 0, 0, 0, 6, 7, and put an extra 0 there for good measure. And that will be the answer for that part there. Work at the value. Don't forget to copy the numbers across in here as well. 1, 2, 3, 4. Work at the value of this. Now the brackets are not necessary because it's just one big product. So I'm going to rewrite it without the brackets. I'm going to rewrite the numbers first because we can. In mathematics, when multiplying numbers, the order in which you multiply doesn't matter. So these two come first, and then the indices come afterwards. So 3 times by 9 will give you 27. 10 to the 7 times by 10 to the 6. And the numbers on the bottom, when the bottom numbers are the same, we add the top numbers. 7 add 6. Okay, so you might be thinking, yeah, finish the question. The question is finished. No, the question is not finished because this here is not standard form. Because the number is too big. It should be between 1 and less than 10. So the decimal point is currently here. Let's make it into 2.7. So from here, you have to jump. From here, it's jumping 13 places forward. And got an extra jump this way as well. So we got now 14 jumps from that new position. 13 jumps forward here. And then move back one, an extra jump. 14. Okay, next question. Coming towards the end of the paper. I have a feeling it's going to take us probably another half an hour. So question number 18. Triangle ABC is drawn on a centimeter grid. A is that point, B is that point, C is that point. It wants us to enlarge the triangle with a scale factor of a half, center 0, 0. Scale factor of, even though they mentioned the word enlarge, because they put a fraction, it actually means you're making the thing smaller. Because a half fractional scale factor actually means make it smaller. Center 0, 0 means where we start the enlargement from, which is from here. So what we need to do first of all, okay, we need to draw lines out from the center of enlargement through the existing points. So from here we draw lines out, intersecting the original corners. So this one line goes through 2. That's okay. So here's the center. Okay, what we're going to do now, we're going to... Okay, now what we need to do, measure this distance here. This distance here is 2 diagonals. So 2 diagonals times by so that distance of 2 will now become 1. Okay, now this distance, now these 2 points are along the horizontal, along this line. So that second point, we don't even need to work it out. It will be straight along that line as well, and it matches there. So that point will go down to here. That point comes there because these 2 points are horizontal. Okay, so these 2 points are horizontal. They have to be. The second point has to be here. I call this A dash, B dash. So we can start to already redraw the shape. Now, the distance for C is 1, 2, 3, 4, 5. So we got 5 to C. So 5 times by a half will give us 2.5. So here we go. 1, 2.5. So the original distance from origin to C was 1, 2, 3, 4, 5. 5 times by the scale factor of half will give us 2.5. So now we're going to remeasure 2.5. 1, 2.5, which gives us that. Okay, and then it goes here. Work out the area of triangle PQR. Okay. Triangle PQR is an enlargement triangle ABC. Scale factor, here we go. Here's P. Okay. Now that we've drawn the shape, we can now work out its area by using the scale as well. So we have area is equal to base times by the height divided by 2. So what is the base? Base is 2. The base is 2. What is the height of A? Originally it was 1, 2, and 3, and now the height will be 1.5. And then we divide it by 2. Okay. So these 2 will cancel out. And that will give you 1.5 centimeters squared. Okay, now in this question here, this part, drawing this part was I've done this as an extra activity. All we need to do to actually work out the answer here for the area is we need to halve these original lengths. So 1, 2, 3, 4. So that becomes 2. We have 1, 2, 3. That becomes 1.5. And we got our measurements. This was an extra bit of practice on how we draw enlargements. So this is not necessary to do this particular question. All we need to do is measure 1, 2, 3, 4. Half it gives you 2. And we have a height 1, 2, 3. Half that gives you 1.5. So the calculation that we've done here at the bottom can be done without drawing this diagram here. So, but that diagram is there, it's just giving you an extra bit of theory on how we draw enlargements with a scale factor of a half. So you can do it just by looking at the measurements, halving them, and working out the area. So this part here, which I just done here, was a bit of extra, okay, extra revision. Well, that question finished. And then we have the next question. Okay. Wendy goes to a fun fair. She has one go at the hoopla. She has one go on the coconut shy. Okay, so we have probability 0.4, 0.3. Complete the probability tree diagram. Now, so we got two different events. Event number 1, event number 2. So these probabilities here must add up to 1. So 0.4 and 0.6 will give you 1. 0.3 add 0.7. The question now says, work out the probability that Wendy wins at hoopla and also wins on the coconut shy. So for that, I'm going to use my... So she wins both of them. So she's got to win hoopla and also coconut shy. So we're going to come along here. So what do we say? The probability of hoopla, probability of the coconut shy, that's win and a win, is going to be 0.4 and 0.3. And in probability is changed into a multiply. 0.4 times by 0.3 gives us an answer of 0.12. Okay, solve the simultaneous equations. Right. When we're solving simultaneous equations, what do? We have to look at the coefficients of x here, which is 5 and 4. Coefficient of y, which is plus 2 and minus 3. Coefficients of the multipliers. Now we need to make the coefficients either equal to each other or opposite to each other. At the moment, none of these are that. So I'm going to choose y. And I want to make y opposite. Choose y and make the coefficients opposite. So how do we do that? So that's plus 2 minus 3. We multiply this plus 2 by this minus 3. By the 3. And we multiply this minus 3 by the 2. So we multiply each coefficient by the other coefficient. So we should get a new set of equations now. So I multiply this by 3, that by 3, and that by 3. So we get 15x add 6y is equal to 33. That was original equation number 1. That's 1.1. That's original equation 2. So now double everything in the second equation. So 4x times by 2 is going to give us 8x. Minus 3y times by 2 will give you minus 6y. And 18 times by 2, that'll give you 36. Okay. Now, the question is in the situation where we need it to be. And now I am very happy that the coefficients of y are now opposite. We now have a plus 6 and a minus 6. That's excellent. How do we eliminate opposite coefficients? By adding. So we have 33 add 36. And we have 15x add 8x. And these numbers here, plus 6y, minus 6y, they get eliminated completely. Because when you add them up, it gives you 0y. We don't need to write that down. So we have 23x is 69. Now, we need to solve that. So the opposite of time by 23 is divide by 23. So how many 23s fit into 69? That will give us 3. Okay, so now we've just worked out the x value. I'll move this up a bit. We have to now work out the y value. To work out the y value, we need to substitute in the x value. Substitute this back into any one of the equations. So that's equation number 1. And I'm going to pop this into here. Substitute. 5 times by 3 plus 2y is equal to 11. So 5 times by 3 will give us an answer of 15. Okay, we need to solve this. The method for solving, start at the y. Time by 2 is going to be called the first action. Add 15 is called the second action. Always with the last action first. Opposite add 15 is minus 15. This step here is a step that most students get stuck. They go, oh, I've made a mistake. I got minus 15. I've only got 11. I'm going to get a negative answer. And my answer to that is, we're doing maths. Negative numbers are welcome. So our fractional numbers, it's all good. So 11 minus 15 will give you minus 4. And then we move the multiply by 2 over. Opposite time by 2 is divide by 2. So minus 4 divided by 2 will give you minus 2. So the solution will give us x is equal to 3, y is equal to minus 2. Okay, next question. Question number 21. We have our circle theorem question. Okay. B, C, and D are points on the circumference of a circle, center O. A, B, and AD are tangents. Okay, what I like to do with my tangents, I like to extend them. Okay, work out the size of angle BCD. BCD. So that's the angle that we're talking about. Angle BCD is the angle in C. Give a reason for each stage you're looking at. First of all, let's look at this line here. This line here and this line here goes from the center to there. That's called a radius line. Okay, the radius always meets a tangent at 90. Okay. Okay, so OBA is equal to angle OBA is equal to angle ADO. So we have our 90s. Okay, so now in our shape, this shape is coming to life. Now we have a quadrilateral. So the angle sum of a quadrilateral is 360. So if we look at this shape over here, which is a quadrilateral, these angles must add up to 360. So what we say? We say 50, add 90, at 90 at this angle here. Call the angle here BOD. BOD. Okay, so we say 50 at the 90 at the other 90 at BOD is equal to 360 degrees. So what we're doing now, we're trying to work out this angle. This angle is the key to working out the angle over there. We need to work out this angle here. Okay, so 50 at 90 will give us 140. 140 at 90 will give us 230. Okay. Okay, right. Now, if you want to work out BOD, we need to move out the 230. So the opposite of adding 230 is minus 230. So we say now BOD is equal to 360 minus 230, which is 0, 3, 1. So that gives an angle of 130. So we now know that BOD here is 130 degrees. Okay. Now there's a theorem that links this angle with that angle because of this other shape we have here now. This one's called the alternate segment theorem. And the alternate segment theorem okay, which means that this angle here is always going to be double of that angle in there. This is the chevron shape that we make here. So here's our arc. So on this arc here, we have this angle made, and on the same arc, we have the angle there made. So these two are connected in the sense this one's always double of that one. So we have our arc over here. This is our arc. And this angle here is made on that arc, and so is that one, because it comes from there. This angle here is always double of that angle. So we say now that BCD is equal to half of BOD. So this angle here is equal to half of the angle there. We know the angle is 130. Half time by BOD is equal to 65 degrees. Okay, so the angle is 65 degrees, and that's with all the explanations. The radius of the circle meeting at 90, angle sum of quadrate is 360, alternate segment theorem of the circles, all of that all together. That's all reasoning and explanation. Let's move on to the next question. Okay, this video is running live. There's no way of me stopping my webcam and then restarting it, so I'm going to have a 1 minute breather because I've been talking now for the last an hour and 55 minutes. So you have a look at the next question and think about histograms, and I'll come back in about a minute. Okay, folks, here we go. That's the end of that 2-minute break. Few pages left. Okay. Right. The table gives some information about the speed in kilometers per hour of 100 cars. On the grid, draw a histogram for the information in the table. Okay, keyword here is histogram. In histogram, what's the formula? Frequency density is equal to the frequency is equal to class width. Frequency density equals frequency divided by class width. And that's the formula we use for histograms. On the grid, draw a histogram for the information in the table. So now let's have a look. Actually, I've used up some of the space. We need to first of all make a column here for class width. So class width is how wide is the class? The class of data. 65 take away 60. 70 take away 65. 80 take away 70. And 100 take away 80. So as you can see, the class widths here vary from 5 to 10 to 20. So we don't expect to get the same. We're not drawing a bar chart. We have the same widths. So the width here is 5, the width here is 5, the width here is 10, and the width here is 20. And those widths, you will find them along the bottom over here. So if you were just quickly mark on 60, 65, 65, 70, from 70 it goes to 80, from 80 it goes all the way across to 100. Now, we need to work out what the frequency density is. The frequency density is equal to the frequency divided by the class width. So it's this number divided by the class width. So 15 divided by 5, that gives you 3. 25 divided by 5 gives you 5. 36 divided by 10. And then we have 24 divided by 20. Okay, when you divide it by 20, if you want to do that Okay, first of all we can do is 24, we can divide it by 10. That will give you 2.4, and then we divide it by 2, which will give you 1.2. So 24, when you divide it by 20, that's like a quick mental way we do it. Divide it by 10 first, then divide it by 2. That's the same as dividing by 20, and that will give you 1.2. Now, so we need to have this frequency density here will be our vertical scale along here. Frequency density. Okay, sorry for that interlude there. So our frequency density, we need to go up to a maximum of 5. So we're going to calibrate our scale now. 1, 2, 3, 4, and 5. Okay, now that we've got this is really our, in a sense, our y-axis. So we are now going to do from 60 to 65, which is over here. We have to do the height of 3. So frequency density equals frequency to our class. That's the formula we're using for these questions. We're going to now start to draw the bars. So from 65 to 70, we have 65 to 70. We have our height is 5 for that one. So we'll go right to the top. So 65 to 70, I've drawn a bar, height of 5 from between these 2 points, all the way up to 5. Now the next one says 70 to 80, we'll have a height of 3.6. That's our height. So let's go 70 to 80, a height of 3.6. 3.5 is here, 3.6 is here, and we need to go across, all the way across to here, and bring it down. Okay, so we're doing the third bar. Now the fourth bar is going to be the wide one. So now we got from 80 to 100, and the height will be 1.2. So we go to we got 80 to 100, and the height will be 1.2. Here's 1, here's 1.2. And there's a histogram complete. One other thing to note is when we're talking about frequency, we are talking about the area of the bar, of any bar. The frequency density is over our y-axis, and the class with the data contains, this is the class, this is the data. Here, speed, that's always going to be along our x-axis. and that's from where we get class width from. Work out an estimate for the number of cars with a speed of more than 85 kilometers per hour. So what we need to do, we go to 85 kilometers per hour. 81, 2, 3, 4, 5. And what we need to do now is to work out an estimate. We need to work out the area, because the area is the frequency, which is how many. So we need to work out the area of this part here, which I'm going to highlight. Okay, so let's have a look. That's 85 over here. So from 85 to 100. So the base of that's going to be 15. Remember, we're working at area. And then the height of this bar is going to be the height of the original one, which is 1.2. So we got 15 times by 1.2. Okay. Let's split that up into two parts. 15 times by 1.2 can be done as 15 times by 1 and 2/10. Okay, so we can think of a way to do this decimal question. So we do 15 times by 1, which is 15. 15 times by 2/10. So we're breaking down this decimal numbers become a fraction. Break the fraction down into two parts. So 15 times by 2/10, we divide that by 5. Divide that by 5. Divide that by 2. Divide that by 2. So that will give you an answer of 18. So in this pink region here, we have 18 cars. Okay, 18 cars. That's the area. So our final answer is 18 cars. So the first part of this question, where we have to look at class width, the frequency density. This is the traditional type of a histogram question. And then we have to put the scale on the frequency density side, y-axis. We have to draw the graph. This is the traditional side of a histogram question. This here, this part here, part B, is the more thinking part of the question, where we have to now apply our knowledge of frequency, meanings, area, looking at the chart, what does it mean from the chart, the pink area, working out the length and the width, and working out the area to give us the frequency, the number of cars in that section. So let's move on to, without any further delay, let's move on to the next question. This video has now gone into the 2 hours and 10-minute mark, and we have got just 4 pages left. So please bear with me on this next 4 pages, and then we can finish this video and upload it onto YouTube, onto the website. Okay, and if you want to search for this video, you search it under 1mao1h 1-to-1 tutor in the YouTube search. Okay, let's move on. Question number 23a says simplify fully x squared plus 3x minus 4 divided by 2x squared minus 5x plus 3. What we have here is an example of 2 quadratic equations. We need to factorize both of them and then cancel. So the first one, two numbers that multiply to give you minus 4 and add up to 3. Got to add it to plus 3, so the first one looks good. Okay, minus 1 times by plus 4 is minus 4. Check. Minus 1 add 4 is plus 3. Check. Correct. So we put them in there. Just change color. Now we're looking for the factors of 3 for the bottom one. And we need some negative factors because we've got to multiply to give you a plus number, but add up to give you negative. So they must be both negative. 3 is a special number. It's called a prime number. It only has 2 factors anyway. So them are the only 2 numbers it can be. Okay, one of them must be x minus 1. Okay, I should just write over here on this side, sorry. Alright, pardon me a second. Right. Now, when we split up the number 2, the number 2 can only be split up into 2 and 1. So our 1's already here. We must put a 2 on this side. Okay, and then we will have to put our minus 3, which is the other number, in this bracket instead. And let's double check that this gives us the correct answer. That gives you 2x squared minus 2x minus 3x. That gives you minus 5x, and that gives you plus 3. So it does actually multiply, add back to give you our original value. Okay. Okay. It is. So now that we've got the equation in the correct format, we can cancel the x minus 1 with the x minus 1. These will simplify because it's a product here, they can cancel. So you're left with we are left with x plus 4 over 2x minus 3. So that should be our final answer. Okay, next question. Write as a single fraction in its simplest form. What we need to do, we need to make these fractions equivalent. And the way to make them equivalent is multiply this fraction by this bottom part, multiply this fraction by that bottom part. So let's do that then. So this fraction here, we're going to multiply by this one. Top and bottom. It's called making equivalent. And you multiply this one by that one. Okay, right. Let's now work it out. So we get now 4 times by x is 4x, 4 times by minus 2 is minus 8. And at the bottom should be the same. 3 times by x is 3x, 3 times by 2 is 6, and now the bottoms are the same. Now, when the bottom fractions are equivalent, so here's our fraction. Now the denominator is the same. That's called equivalent fraction. They're both the same type of fraction. We just need to write it once and add the top. So that gets replaced, 2 of those with 1, and then we add the top number. So we have 4x add 3x is 4x, add the 3x is 7x, minus 8 and 6 will give you minus 2. And there we go. We finished that question. And that question can be copied up. Done. Okay, I'm nearly finished. I know it's taken us 2 hours and 15 minutes, but we're nearly finished. Okay, I've just been told we've missed one question out. Express the recurring decimal 0.281 as a fraction in its simplest form. Okay, with these type of questions, what we say is this. So we say let x is equal to 0.2818181. So the 2 is the number that doesn't recur, but the 81 recurs and recurs. So that's where the recycling happens. So the 0.2 is just not a recurring number, but 81, 81, 81 goes on and on and on and on until the cows come home. Okay, what we need to do, we need to get the numbers to match up, the decimal numbers. So when we do the next ones, let's try 10x. That'll give you 2.81, 81, 81, 81, 81, 8. As you see here, the numbers here don't match. They won't minus to give you nothing. So we then try 100x. That gives you 28.1, 81, 81, 81, 81, 81. And again, none of these numbers here at the moment are giving us something that we can take them away. Let's try 1000x. So we can multiply this by 1000 now. So now we get 281.8181818181. And now we find out that they match. Okay, where do they match? So after the decimal point, this 8 matches that 8. This 1 matches that 1. This 8 matches the next 8. So now everything here matches everything here. And the idea is to minus these. So we have 1000x and 10x. So if we say what's 1000x minus 10x? 1000x minus 10x will give you 990x. Now we have left over here 281.8181 minus 2.8181. So 281.8181 minus 2.8181. So what we can see from here, as this part here will cancel each other out. So we've got now 281 minus 2. 281 minus 2 will give you what? So you've got 990x. 281 if you minus 1 gives you 280. And that will give you 279. Okay, so opposite of multiplying by 990 is 279 divided by 990. Okay, I'm going to copy this question up here because I'm running out of space. I'm about to crash off the paper. So x is equal to 279 divided by 990. Okay, so what will that give us? Now, don't forget this is non-calculated paper. We need to divide. Let's start dividing by numbers we know will work. Let's divide by 3, top and bottom. So 3's into 27 will go how many times? 9. 3's into 3 will go how many times? 3. 3's into 9 is 3, 3, 0. Let's now divide it by 3 again. So we are simplifying this fraction without using calculator technique. Okay, so 3 goes into 9 3 times, 3 goes in 3 once, 3 is in 330 will give you 1, 1, 0. So we now have 31 over 110. 31 is prime number, so we can't go any further. So that is our final answer. So the technique here is to get the numbers after the decimal point to line up. Once they line up, we know that when we're going to take these two numbers away, this number, take away that number, we know that the decimal part of the number will disappear as it did here in the calculation to give us two nice whole numbers. That one was already whole, that one became whole over here, the decimal part. Then we, opposite times is divide, which we've done, and then we slowly cancel it down until we can't cancel it down any further. Okay. Okay, the diagram shows a solid metal cylinder. We're getting towards the very last pages of this paper now, and the questions are getting towards the A star. We get 3 more pages left. It says that the cylinder has a base radius 2x and height 9x. The cylinder is melted down and made into a sphere. So we have a cylinder. The cylinder is melted down and made into a sphere radius r. Find the expression for r in terms of x. Okay, so what do we know? When you melt the cylinder down into a sphere, the volume will stay the same. So the volume of the cylinder will be the same as the volume of the sphere. They haven't mentioned anything here about volume. So that's for you to figure out yourself in the question. Now let's have a look what the volume of a cylinder is. Volume of a cylinder is equal to the area of the cross section, which is going to be pi r squared. That's the cross section over here, times by the height. So at the moment I'm just looking at the original formulas. Now what's the volume of a sphere? Volume of a sphere, you'll find that at the front. Okay, volume of a sphere, you'll find that at the front of the paper. Volume of a sphere is here. 4/3 pi r cubed. So the volume of the sphere is 4/3 pi r cubed. So what we know is that the volume of this will be the same as the volume of the sphere. Okay, let's carry on from where we are. Let's now put in the values. So we have pi times by the radius times by the height. So here's our radius, here's our height, and the height is, okay. On the other side we have 4/3 times by pi times by the radius. Find an expression for r in terms of x. The cylinder is melted down and made into a sphere of radius r. Okay, here's our r. Okay, let's try to simplify some of these expressions first of all. So we have pi times by 2x squared. Pi times by 2x squared will be the same as saying 2 squared and x squared. I'll give you pi times by 4x squared times by 9x is equal to 4/3 pi r. Now, since we have pi on both sides, we can divide this side by pi and divide that side by pi, so the pi disappears. Okay, now we got 4 times by 9. 4 times by 9 will give us an answer of 36. X squared times by x will give you x cubed. Okay, and on this side we have 4/3 r. Okay, now we need to rearrange this and make r the subject. So, opposite of divide by 3 is time by 3. Opposite of time by 4 is divide by 4. So this is called cross multiplying, where the bottom number goes to the top and the top number goes to the bottom, because opposite times is divide on the bottom and opposite of divide is times on the top. Okay, now let's see if we can cancel this down. Let's see if we can cancel this down, which you should be able to. This is the product, and that's, so divide that by 4 is 1. Divide that by 4. Okay, so we're left with 27 x cubed is equal to r. Okay, we have r cubed. R cubed. The cube went on a holiday. Let's put it back in. Okay, now we need to find out in terms of r. Find in terms of r. Now we've got r cubed in the question. So what do we do now? So r cubed start of here. Went on holiday. We put it back in. Here we go. We take the 3 over. Opposite of cubing is cube rooting. So the cube root of 27 will give you 3, and the cube root of x cubed will give you x. And we finished. I can't fit the whole question in one on the video image. So the volume of the cylinder, the volume of the sphere, that's the formula for the cylinder volume, sphere. Remember in the cubed, bring it all the way down. Always check back through your working out. Okay, we're cancelling of pi's, we're multiplying at the squaring the items out. We are cancelling, cross multiplying. We're doing some more simplifying. Opposite of cubing is cube rooting. Cube root of the 27 gives you 3. Cube root x cubed gives you x. And we're done. That question is worth 3 marks. Okay, the next part is transformations. Transformations of functions. Here's our original function, y is f of x, which means any type of function that is, which they've drawn for, which looks like a quadratic function here. Now, when they put a minus 3 inside the function here, by putting a minus 3, which means that we move the whole graph 3 places to the right. Minus 3 means inside the function means move to the right. So what we have to do here, get the point 0. So you have 0, we add it to 3, and that starts at 3. So we have 2 add 3, that gives you 5. Okay, so we have this point here, which is at 1, we add 3, that gives you 4. Okay, so we have moved 1, 2, 3. That's when you have a minus 3 inside the function. That minus means move right 3. Okay, this point, we move this point here to be easier. By 3, 1, 2, 3. Okay, this point here by 3, 1, 2, 3. Okay, this point here by 3, 1, 2, 3. So we should be able to redo the graph. This point here by 3, 1, 2, 3. There we go. And if the number in here was a plus 3, we get the whole graph from here and move it that way by 3. Okay, let's move on to the last question. On the grid, sketch the graph of y is equal to 2 of fx. Okay, so the original graph was y is equal to f of x. Now they put a multiplier outside. When you put a multiplier outside, this, what that does to the graph is the following. Okay, we double the points. Okay, now this point here, when you double a 0 value, you get 0. So if we double that y value there, that value there, minus 1 becomes a minus 2. So far straight away, so we're going to double all the coordinates of the original function. So the original function is f of x, and then we're going to double it. So what's that coordinate? 0. If you double a 0, you still get 0. If you double the x coordinate of 0, you still get 0. Okay, so we have here our y value here is 0, that one's 0, gets doubled to gives you another 0. Here the y value is -1, we double that gives you -2. So let's have a look for the values. So if you double 3, the height of 3 will give you 6. So the graph gets steeper. Here we got here a height of 3, a y value of 3 here. If you double that, okay, that will go to 6. Oops, that's gone a bit mad. Okay, let's get a bit of text and get rid of all these lines here. Okay. So the effect of doubling it, it makes the graph more steeper. If you were to halve it, it will make the graph come out like that. Okay. If you made it 3 times, the effect will be even more steeper. Okay. I hope you have enjoyed the model answers that I've given for this paper. It's taken 2.5 hours. And as we said earlier, if you want to see this lesson, this maths paper being recapped, please go to YouTube and put in your search engine Imran Iqbal 1-to-1 tutor, all one word, and you should find this video there. Hopefully this benefits you. If it benefits you, please pass the link on to your other friends and family members so they can benefit from going through this paper as well. Okay, thank you very much, Mr. Imran Iqbal. That's the end of today's session. That's a 2.5 hour video.